I want to call F1. I break it down, and another force, let me using another color green, que es F2. Actually, the 4F is equal F1 plus F2. Remember the addition of the vector, and graphically is the parallelogram rule. So you add in this and this. Okay, so this equation is perfect. However, the force in blue color is in the same direction of the motion. However, the force green, que es F2, is orthogonal, is 90 degrees with the motion. Therefore, you break it down into force. The work doing by the force F1 plus the work doing by the force F2. And it's obvious that this is 0, because when the angle is 90 degrees to the motion, that force, that's me, in other words, guys, this force do not do any energy. No, and we can delete mentally. And the only force is really actual act is F1, que is the component in the same direction of the motion. So the conclusion is the work done by the force F, que is the total, is equal only the work done by the component F1. Okay, que is the only force in the same direction of the motion, que is actually the same. The force que produce a work. Okay, this is the idea. So this is important not only in the work, and another when you take calculus 3, so you need to take calculus 3, and you see another application of this. Not necessarily work is one example to illustrate what is important. The decompose the force. Now, so let's go to the mathematical part. The mathematical part is, look, we suppose that we have one vector. Okay, called B. This is important vector. But we have another vector, not necessarily big, but this vector indicates another direction. Double. So what's the goal? The goal is decompose the vector B onto the direction W, no? And we have two vectors, B1, and we have another vector, okay, well, let me use in different color. This, remember the color for this is B2 vector, and entonces en blue color es B1 vector. And for sure, B1 plus B2 are orthogonal because the angle in between that vector is 90 degrees, and also B1 plus B2 is equal to the original vector B. And this is the idea. The idea is you have a vector B, we have another vector W can indicate the direction in which you want to project in, and you project it onto that direction, and also by complementary idea, we have another direction que es 90 degrees, que es B2. This is the idea. Do you understand the idea? Now I want to discuss in the formulas. And now we are doing example and in the story.
Can I take a picture, Professor, before we go to the...
Yeah, but take a picture when I finish.
Okay.
Okay, because we have, this is just the beginning. Blah, blah. Now, it's important to define, you need to be familiar with this terminology. Look, B1 vector is called projection, P-R-O-J, projection of the vector B onto the direction W. So I need to be familiar, guys. Projection P R, O, J. Then you put here vector A onto direction B. So you put the original vector okay, you want to project in, and you put here down the direction in which you want to project in, no? And this is B1. Okay, and the absolute value, the magnitude of this vector is called a component. Component of the B vector onto the W vector. Entonces let me try to translate this in one good Spanish. Spanish or English to understand. This is the vector. This is the vector. This is the vector. And this is no vector. This is a scalar. And some book call it no component, call it a scalar projection. This is projection, que es a vector, okay. And the other is a scalar projection or component. This is COMP is component. Okay, not bad. Entonces now, the component applied trigonometric, the component of vector B is just the length of this blue vector. It's the length of this blue vector. And the length of this blue vector is the length of the original vector, que is magnitude vector B, multiplication by cosine theta. And who is theta? Well, theta is this angle. Okay, I have no idea. At the beginning, I have no idea, but you know how we compute this angle because remember, using the dot product, we discover in one moment que cosine theta is equal the dot product B, dot product W, divided by magnitude of vector. Multiplication, no? Magnitude W. This is a formula to compute the cosine. As you want to find theta, well, you apply cosine inverse. Okay, perfect. So you replace. Entonces, magnitude B1 is equal magnitude B multiplication by cosine, but cosine I'm using that formula. Dot product. This is vector, and this is dot product. Different to this, case multiplication. This is regular elementary basic multiplication. If you want, not necessarily indicate or nothing. And before you know case multiplication, no? But this is a special multiplication that's dot product. Okay. And divided by something, divided by magnitude B and magnitude W. Super. And you can see clear like water, okay, this quantity is the same and cancel out because it's just a number. And the answer is then B dot product W divided by magnitude of W. Okay, so far, the only thing I don't finish, this is just the beginning. We're in the middle. Magnitude of the vector B1 is B dot product W over magnitude W. Entonces let me come back to this. Oh, look at that, magnitude of B is the component. So using this new notation, que es a little bit confusing, pero you are little bit familiar, is BW is exactly magnitude of B1, no? Que is now B dot product W divided by magnitude of W. I finish, no, almost, I finish. Okay, entonces I realize something. Wow, look at that. W vector divided by magnitude of W. Oh, this is the unit vector. This is the unit vector. It's a unit vector in W direction. Okay, let me call U, because U is a capital unit vector, and the W direction. So you replace this to find the component of the vector B onto the direction W. It's super easy. It's multiplication, so dot product, perform dot product between vector B, is the original vector, that the unit vector and the W direction. And this is the formula. The formula for the component, no? Okay, the component, I repeat again, is the length of the blue vector. It's the component. However, no, this is give me a scalar because it's dot product. And suppose I compute that, the answer is 20. Okay, 20 is no vector, 20 is a scalar. Okay, because you find the projection. So we come back to this. So B1 vector is equal the component, que the component is the magnitude, so magnitude multiplication by the unit vector. So it's the component is equal to the component, the B vector onto in the direction W multiplication by the unit vector, but this is the vector. This is a scalar number, but this is no vector. This is a unit vector. This is vector, and the multiplication both guys give me B1. Wow. Okay. And what about B2? B2 is easy because the connection between B and B1 and B2 is this. Therefore, B2 is equal the original vector B minus B1. And this is the formula, guys. One formula and two formulas. If you want to condense it together, look, some people prefer the formula. I do not prefer the formula. I prefer the concept, the interpretation of the thing. Okay, one guy say, wait. Component is B vector. I try to copy this. And unit vector is W. This is the dot product, guys, divided by magnitude W. And now, in order to get B1 vector, you multiply it by the unit vector again, but like a vector. Entonces es W divided by magnitude W. So you put together, entonces es basically dot product B dot product W multiplication by W vector. This is regular multiplication, no dot product, divided by this and this together, que es the same, magnitude vector W square. This is another way que some students prefer to write the formula. In my opinion, no. In my opinion is, look. If you want, using the logic, if you want projecting the vector B onto the direction W, the first thing you should do is compute the unit vector in the direction W. Que I suppose que es a short vector with the amplitude is 1, because it's a unit vector, in the same direction. And you perform the dot product between B and UW vector. And you get that. It's a number, just a number. After that, this number multiplication by the unit vector, because this is a vector in the same direction of W, and B1 is in the same direction of W, no? But the magnitude B1 is given by the component. And multiplication, this component of this magnitude times the unit vector, and give me B1, que es perfectly, is a new vector que contain the amplitude equal the component and the same direction of W. And for finding B2, when subtracting the original B minus B1. End the story. That's it. You get the idea? Let's see one example, only one. Because in the review we have more. And that's it. Confusing? Some people say, no, I never understand this. I never understand what mean component. Do you understand or no? Component, projection, a little bit say que no. I understand the language of the student, but the time is a little bit, no. Okay, let's see example. And maybe when you finish the example, you say yes. Example.
Oh, Professor, can you go back to this one?
Yeah. Oh, this is complicated. Escape. There you go. Let me try to big picture for you. Okay. If you want, don't take a picture of that part.
Okay, I got it. Thank you.
Okay. Let's move on to the example. In the example, maybe you see clear everything. Example. Suppose that one vector is given, B. Of course, we are working in 2 dimensions. This formula is valid in 2 dimensions and 3 dimensions. But no. I don't want to complicate your life. And the test only 2 dimensions. The vector is 1,3. Are you familiar? Okay, this is equivalent to say I plus 3j. And the another component notation, the way you prefer to manipulate the vector is the same. And we have another vector, que es W, que es the vector formed by 1,1. And the question is find B1 and B2. Who is B1 and who is B2? Well, B1 is a vector, que es the projection of the B vector on the direction W. So B1 is projection. Projection B vector onto the direction W. And B2, no, B2 is the orthogonal projection, some book call it orthogonal projection, que es 90 degrees, no? 90 degrees. So now to find B2 is easy, because the only thing that you should do, so you have B1 in your hand, like a vector, of course, B2 is equal B minus B1, and that's it. So my recommendation is, step 1, find the unit vector U in the direction W. Okay, it's super easy. You compute the magnitude of W. Okay, it's a square root, square each component, 1 square plus 1 square. 1 square is 1, 1 plus 1 is 2, is radical 2. And you divide each component by radical 2. So you get the new vector, que es 1 over radical 2, 1 over radical 2. Boom! And it's the unit vector in the same direction of W. In other words, let me try to explain one more time. Unit vector means que it's a vector in the same direction of W. You see now one simulation in GeoGebra of this example, but it's short because the magnitude is 1. Okay, guys, if you want to express in a more elegant way, you rationalize this guy is radical 2 over 2, radical 2 over 2. Super. Step 1 is find unit vector on the direction in que you want to project. In this case, W direction. Step 2, que is the most important step, perform a dot product. So you perform a dot product between the original vector B, que is the vector that you want to project, and the unit vector W. And magically happen, this is magic. Okay, this give me a scalar, and this scalar is the component. It's the component of the vector B onto direction W. And remember, the component is a scalar number, right? Okay, let's do it. So B is 1,3. It's giving at the beginning dot product radical 2 over 2, radical 2 over 2. Okay, entonces remember the formula for the dot product is multiplication component by component, no? You multiply this and this, okay, radical 2 over 2, and you multiply this and this is plus 3 radical 2 over 2. Same denominator, nice. 1 plus 3 is 4 radical 2. Reduce the lowest term to radical 2. And this is a component. So at least I know that the vector B1, the length, the amplitude of this vector B1 es 2 radical 2. Bueno, este 3 es, well, este 3 is find B1. And find B1 is super easy because it's the component. It's a number, scalar, multiplication by the unit vector. Unit vector and the direction double. This is the vector. So basically is the component is 2 radical 2. And the vector unit vector was here, I have here. Look, this guy. Okay, the answer for the step 1 is radical 2 over 2, comma, radical 2 over 2. Entonces now es multiplication es this, bueno, es easy, ¿no? Es 2 radical 2, ¿no? Over 2, ¿no? Over 2, no, over 2. A ver, radical 2 es 2. Es 2. Okay, this is 2, comma 2. Erase. Do you follow me que es 2, 2? 2,
No.
No, okay. 2 radical 2 times radical 2 over 2. This 2 is cancelled. And radical 2 times radical 2 is 2. End the story.
Yeah, got it.
Okay, this is B1. And what about B2? Well, B2 is easy. Okay, this is the step 4. Find B2. B2 is B minus B1. B is the original vector that's given, que es 1, 3, subtracting the vector 2, 2. Entonces you're subtracting 1 minus 2 is negative 1. And 3 minus 2 is 1. Okay, and you break it down. The idea is you break it down. The original vector B, que is 1, 3, and 2 vector B1, que is 2, 2, this is B1, plus B2, que is negative 1, 1. You want double check it, everything is okay. 2 minus 1 is 1, and 2 plus 1 is 3. Done? And also, wow, professor, and this vector are orthogonal. The angle in between them is 90 degrees. Yes. How you prove that? Well, you prove in GeoGebra, Geometrica, you can see now in few seconds. Or you perform the dot product. B1, dot product B2. And remember, you multiply the component. 2 times negative 1 is negative 2. And 2 times 1 is positive 2. The answer is 0. You know very well that when you perform the dot product and the answer is 0, it's because the angle in between the vector is 90 degrees. Orthogonal. Okay? More clear, Anuela?
Yes.
We need more practice. This is for doing practice. In the review package, you see 3 examples, 4 examples. I don't remember very well. But I want to show you, okay? I want to show you in detail the geometry. Remember, one picture is much better than 1,000 words. I blah, 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 blah. But when you see a picture, you see clear everything. So I prepare for you one script in GeoGebra Classic. Okay. Where is this? Like that, boom. Let me share the screen with you. GeoGebra. GeoGebra is a little bit more complicated. Desmos is easier, but Desmos don't allow us working with the vector and don't allow us working with the three-dimension something, no? Object. Okay, so I plot the two vectors. I flashing the vector B is the original vector. Bam, 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 bam. And the vector W is this vector. Bam, 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 bam. Okay, it's the vector que give me direction of the projection. Okay, entonces for one moment I compute the unit vector. Okay, let me delete B for a moment. Unit vector in the same direction. You see, this is a unit vector. I put in purple color. A same direction of W, but it's a little bit short because the magnitude of W is radical 2. It's not too short. It's 1.40 something. And this is unit vector and the magnitude is 1. This is unit vector. Okay, so I perform the dot product. I did that. Dot product. Multiplication. This is the component. B1 is this. Boom. Now, see, you're projecting the vector B onto direction this, you get the red vector. And the orthogonal projection is this. When I this is this, yes. Okay, so you translate to this. I don't know why. Let me try to complete the idea. Suppose this is a little bit complicated. Vector, using start point. Okay, oh, but I need to declare 1 point. Perfect. Okay, let's do it. Delete that. Suppose que I declare 1 point. Que es el point A. Que es equal, 2,2. 2,2, nice. 2,2. What's going on? Because it's defined before point. 2,2. Okay, this is easy. This vector. So the thing I try to do, a continuation B1, no? To see more clear. So B vector is point is A vector. And here is A plus. The second vector, the second piece is A plus B2. B2. No, but I don't lie. I put a. Okay, I put it. I did that. Wow. Actually, I did. Okay, look at that. Here, over there. This input. You see the projection or no? Do you see the projection or no? It's called B2. B2 B1. This, let me see. B1, B2, yeah. Do you see or no? More clear now or no?
Yeah, it's clear.
So the idea is you have a vector B, -1, A, B, C, D, and you want to project it in another direction of another vector that's given. It's given two vectors at the beginning. One is the direction, and another is the vector you want to project. Okay, so we are ready to start review package. Let me try to. Okay, I don't know if you see or no the whiteboard. Let me try. Do you see the whiteboard? Let me try to find the well, okay. This is the new whiteboard, those I am not familiar with some detail. Okay, this one. File. Okay, I try to find the subject. Okay, there you go. Preview for the test work. Okay, I have. Okay, now open. Okay, good. Open. Select. Okay, any page. Or select. Okay, this is the review. I have the review in the whiteboard. Page number 1. Let me enlarge. Page number 1. Do you see very well or no? Little bit?
Yeah, it's kind of small though, Professor, but it's okay.
No, I can't make it zoom. The problem is I make it zoom, entonces I have no space for the board. No?
Yes,
It's
that is
okay.
the problem. That is why it can be. We can
Okay.
see it from our computer.
Another computer.
I said like we can see from our computer, like because you sent it to us.
I understand. Okay, now I make it zoom. To see now clear or not?
Yes, it's clear now.
Okay, because the first question say the polar coordinate for the given point, for the point are given. Find the rectangle. Okay, it's a conversion. So I suppose the question 1 say we have the point, que es 3, 2 pi over 3. Obviously, this is r and this is theta. I need to convert to rectangular. Rectangular is x, y. Correct? Okay, so now the formulas or the equation of the conversion is x is equal r cosine theta and y is equal r sine theta. Okay, now who is r? R is 3 cosine 2 pi over 3 and 3 sine 2 pi over 3. Keep in mind that 2 pi over 3 in degree is 120 degrees and lie in the second quadrant. Therefore, the cosine is negative. Actually, okay, don't necessarily do, so using common sense, hello, look, 120 here. And the reference angle is this, okay, 60. And the trigonometric function of the 120, so you don't remember, it's the same of the trigonometric function of the 60. The only consideration that you adjust the sign according to the quadrant. Here I know that in the second quadrant, the cosine is negative and the sine is positive. So if you remember only the cosine and sine of the angle, the fundamental angle in the first quadrant, que is 30, 45, and 60. Okay, this is 1/2, but it's negative 1/2. So 3 times negative 1/2. And it's 3 times radical 3 over 2. So the answer is here. The first component is negative 3/2. And the second component is 3 radical 3 over 2. Que corresponde with the option A. That one. Any question? What part you don't?
Can you zoom it because I can see it like the exercise.
Like that?
Yeah,
Oh.
because like it's a little bit big.
So in that direction.
No, Professor, no, it was good. It was good before.
Okay.
Okay, thank you, Professor.
Any question, guy? This is the moment to ask me any question.
Now, well,
Okay.
that was clear, Professor.
For you. I ask in general, Nuela. Okay. Any question? Everyone saw that or no? Okay, no problem.
It's all good, Professor. Thank you.
Okay, thank you for letting me know. Number 2 is similar, except que number 2 we have the radio negative, que this something is weird. Es the polar is minus 3, 2 pi over 3. Okay, okay. I have no idea who 1 or 2 pi over 3. So you can, if you want, before start the equation, you have roughly idea in what quadrant lie at this point, no? Suppose 2 pi over 3. You start always for theta. Theta in this case is the same, es 120, no? Es positive, entonces es counterclockwise. But the radius is 3, but it's 3, 1, 2, 3 in opposite direction because the radius is negative. So my point is here. This point is here. Do you expect, entonces, in the fourth quadrant? In the fourth quadrant, the x component is positive and the y component is negative. To represent like a rectangular, no? Component. Okay, no problem. This is, in my opinion, it's a good idea. Plot the point a little bit in one corner of the piece of paper. I have some idea in what quadrant lie. And give me information about the signs. Entonces, x is equal r cosine theta. And y is equal r sine theta. But r is negative 3 cosine 2 pi over 3. Similar angle que we working in the last time, que es negative 1/2, no? And negative 1/2 multiplication by negative 3 is positive 3/2. And make it sense, look, this component is 3/2. Super. And the second is negative 3 sine 2 pi over 3. 2 pi over 3, we compute before, the answer is radical 3 over 2, no? Positive. And negative is negative, so negative 3 radical 3 over 2. And the answer in rectangular is 3/2. Comma, negative 3 radical 3 over 2, que es de option A again, no? Let me see. The option A again. All right, let me fix it because I select another option. I am no good in the selection. I fix. Any question, guy?
Professor, I didn't understand why it was on the fourth quadrant.
Well, the reason is because the angle is in the second quadrant, right? 2 pi over 3, 120 degrees.
Yes.
But the radio is negative. Entonces, the radio negative indicate us que es in the opposite direction. So you plot, for example, 3, 2 pi over 3, for sure, that point here. Remember, in polar, we are doing in this order. You rotate first theta, 120 degrees, second quadrant, and you moving out and out from this line, 3 units, 1, 2, 3. But there's negative 3. When there's negative, the interpretation is you flip it in the opposite direction. Clear?
Yes, it's clear. Thank you so much.
One more. One more. This is a good example to illustrate that not always is possible doing by the formula. Okay, the formula is possible, no? But suppose the point, this is opposite. It's giving a rectangular. So number 3 and number 4 is giving a rectangular 0,9. What means that this is x and what means this is y, right? I want to convert to polar, so I need to find r and theta. Important. It's a rectangle. Let me try to do roughly sketch to understand. 0,9 is here. Suppose that segment is 9. 0,9. It's obvious that this distance is 9, right? And this is R. And this is R. And the angle is this angle, okay, 90 degrees. Makes sense? Without doing anything, the answer is 9, pi over 2 in radian, because the answer is expressed, and you know, in radian, the option D. Super?
And why, Professor, is the theta p over 2?
Pi over 2 is 90 degrees. Are you familiar with the pi over 2 and radian is 90 degrees?
Yes. Okay, I got it. Thank you.
Got it, right? Yeah. Suppose you don't see very well this picture. Let's do it by the formula. The formula of conversion from rectangular to polar is R is equal to square root x squared plus y squared. So in our example, x is 0 and y is 9. And 0 is nothing, 9 squared is 81, square root 81 is 9. This is R. But the confusing part maybe is tangent inverse of y over x. Entonces, tangent inverse of y, que es 9, divided by 0. And this is undefined. So I don't know if you remember that when the tangent inverse of undefined is equal 90 degrees or pi over 2. So you can find, for example, in the table I provide you the first day. You remember that or no?
Yes, Professor.
But I recommend when you see when the number or the point is given is on the x-axis or in the y-axis, you use intuition. You plot, you see in that case it's obvious that they are perfect coincidence because one component is 0. Entonces R is the only component que es no 0, ¿no? And theta depende, ¿no? Si es en the y positive es 90 degrees. Si es en the y negative, or you can write like a negative 90 degree or 270 degree. Suppose another hypothetical example, no? I don't want to complicate with the extra example, pero suppose hypothetical. Suppose example 3 complementary. 3 prime. Suppose 0, negative 9. Do you understand that the radius is the same, no? It's 9, positive. But the angle now is 3 pi over 2. Or in degree, 270 degrees. Makes sense, no? Right? You understand or no? Yes, clear or no? Hey, answer me. Suppose que es on the x-axis. Suppose. Suppose que es given this point. Look, 9,0. Well, entonces 9,0 here. The distance is 9. R again is 9. Entonces 9,0. The only 0 que this is 0 number and this is 0 degree or 0 radian. Suppose que es negative 9,0 is in the opposite direction. Entonces en polar would be 9 again, the same radius, pero 180. En degree or 9,5. Make sense? Polar?
Yes.
Entonces I highly recommend, when you see that the number gets given in the problem is or purely no, on the x-axis, on the y-axis, maybe the formula is confusing because undefined. Entonces I don't know undefined. Undefined is no number. Entonces undefined is like an error. Entonces no, much better doing it that way. Do the sketch and you see clear geometrically what is the angle. Okay, now let's move number 4. Number 4. 4 is the point. Uy. Negative 2, comma 2. Why not? Let's do in the sketch. I like very much the logical thing, not the formulas. 2, negative 2 here, negative 2. And positive 2 is down, no, up to here. This is my point. Negative 2, comma 2. Bueno, no, it's your way. O sea, no era say que the formula is easier. Let's do it in both ways. And you take the way that you consider better for you. You know, when the people say easy or hard, don't say anything, because this is totally relative. It's up to you. Okay, depending your learning way to way. So some people learn visual, some learn sound. For example, the mnemonic device Sakotoa, for me, sound ridiculous. Because my learning way to see is visual. So in my imagination, sign, the opposite, hypotenuse. Visual, no Sakotoa. Sakotoa is a sound. To remember, okay. So I explain Nuela different way, and you take the way that you consider better, right?
Right.
Entonces now my learning is visual, very visual, logical, visual. Entonces now my point here. Entonces en polar we expect this radio, que I have no idea how much is this, and this angle. This is theta. Que theta lie in the second quadrant. Correct?
Yes, Professor.
Okay. This is the roughly understanding of the point. I predict something, at least the angle, and let's move on to the formulas. And the formulas say R is square root 2 square, because this is X and this is Y, pero es negative 2 square, ¿no? Plus 2 square. Es obvio que es square root 4 plus 4, square root 8. If you want rationalization, it's 2 radical 2. Because A, you know, is 2 and 4, and radical this is 2, and this 2 is the 2 outside, and this is stay inside. This is R. And theta is the time inverse of Y over X. This is the formula. So I put tan inverse of Y, que Y es 2, and negative 2, que es obvio que es tan inversa, negative 1. But this is ambiguous, because tangent inversa, o sea, what is the angle whose tangent inversa is negative 1? Well, we have two angles that satisfy the condition. One angle is in the second quadrant, que actually is the angle that we are looking for, is 3 pi over 4. In other words, 135 degrees for the people who prefer degree. But we have another, que es 7 pi over 4, que es 315 degrees. And this is in the second quadrant, and this is the fourth quadrant. Okay, entonces, of course, you take the second quadrant because and do the analysis of the sketch, and it was clear for me que es in the second quadrant. Do you see now the big picture, Noela?
Yeah, now I know, Professor.
Now, what's the final answer? The final answer is the radio is 2 radical 2, and the angle theta is 3 pi over 4. Or 135 degrees, but okay, I am doing multiple choice. The option A again. And the test, no, if you want, I grade correct. You write like that, 2 radical 2, comma, angle 135 degrees. And degree, because I like degree, I prefer degree. I understand much better degree, okay, no problem. It's clear. Good.
Good, Professor.
Okay, so far, conversion from polar to rectangular or rectangular to polar in every direction. You are strong. You have 100 points in the test of that part.
Yes.
Okay, nice. Let's move on to the easy part. Is similar, but no points, equations. Equation now. Okay, look. One equation is given and, the letter X and Y represent rectangular coordinate component, no? Write the equation using polar. Okay, you have equation and the rectangular is X squared plus Y squared equal 4X. Okay, you know very well it's a circle. Circle, when you find the center of the radius of the circle, you complete the square, but no. Don't do that. The idea is convert. So we're using the set of the equation can allow me convert from rectangular to polar. Okay, the equation is R is equal square root x squared plus y squared, and theta is equal to tan inverse y over x. Just in case I want to copy the other, case x is equal R cosine theta and y is equal R sine theta, because frequently we use the combination of this equation. Entonces, es obvio que x squared plus y squared es R squared. It's obvious, right? And 4x is 4 times R cosine theta. Make sense?
Yes.
And R, at least one R is cancelled. And the answer is R equal 4 cosine theta. Okay, entonces this is the equation in polar of the one circle. Okay, by the way, the center is located at the point. This is curiosity. You put it in decimal if you want. It's a circle like that. And this center is in 2,0, and this radius 2 in the direction. Same conclusion you get if you take the rectangular. You apply the exactly we are doing in color algebra, complete the square. Pero no, you don't want to do this. Entonces, what option you select? You select B, no? B. Any question? This is only using these formulas and using a little bit imagination. In my opinion, imagination is most important than the formula.
Yes, because you can forget the formula.
Yeah, the formula you forgot. Next month you don't remember. The formula is in the book. You come back to the book and you see the formula. But I remember, because in one problem is most convenient using polar coordinate. And you remember what is the idea behind polar. No? Polar is different. Polar, you define one point using one segment that connects the pole, and the point is called R, is the radius, and the angle from the polar axis to the specific point. This is another way to express it, the point. Okay? Any question in number 5? No? We are the best in Miami-Dade College. My class of the pre-calculus for the summer is totally full. Totally full. Somebody enroll with me? Or no, you two before pre-calculus. You don't need to take Nuela, no?
No, Professor. I'm wondering if you're gonna teach calculus on fall, Professor.
Okay, listen to me. Listen to me. Suppose que I do not teach it, but I'm working as a tutor. Okay, let me tell one story. I teach one student. In this moment, he is in FIU. I don't know. It's a Cuban guy, but I never see in my life, and now we are friends because he go to the tutor service y take calculus 1. So I help you. This is a smart guy, but I help. This is the another level guy of the calculus, of the mathematics. It's advanced mathematics. Calculus 1 and calculus 2. That's the only calculus you need to take because he studied computer engineer. Okay, so now in the tutor you can reach me. Okay, if you want extra time, entonces you pay for me, maybe. Okay, pero no. Si you don't need extra time, it's okay. Okay. You when you see Noela Oliveira, I assist you immediately. You see that you get inside, you need to know my schedule. Pero my schedule is posted. So I give you my telephone number. There are many ways to do it. Okay. I know that you are a good student. The only student that need to get successful in mathematics, I can help. Okay, number 6 now. 6. Well, 6 is weird. It looks like parabola. X squared equal 3y. Okay, but I know very well the set of the equation. I know the x is r cosine theta and y is equal r sine theta. And just plug it in. Entonces es r squared cosine squared theta equal 3 times r sine theta. At least one r is cancelled, you know. Entonces r cosine squared theta is equal 3 times sine theta. Okay, what's that? Oh, es... A ver, let me see. Es sí, ¿no? Like that. Ajá,
Yeah.
you manipulate. Entonces you stop in one moment, pero you don't know si we continue doing something or not. Entonces you compare with the multiple choice. This is perfect. The only problem es que this equation is no explicit, pero okay, I understand. Leave it like that, is correct. Okay, one more and we continue Tuesday. Number 7. All right, let me see what they are. Okay, no. Number 7. Number 7 is similar. X times y equal 1. Yeah, I know that x is r cosine, y is r sine. Substitution. Entonces es r cosine theta multiplication r sine theta equal 1. R and R together is R squared. Cosine theta times sine theta equal 1. Entonces cuando I go here, I don't see any answer that look like similar. The problem is, or the problem was, that they using this identity, double angle identity. I need to know que sine to theta is twice sine theta cosine theta. And that part is exactly that part. So you replace, you divide by 2, both sides. That's actually sine 2 theta over 2 is equal sine theta cosine theta. You replace, it's r squared sine 2 theta divided by 2 is equal 1. Let me try. Wow. Okay. The only thing you should do to look like similar is multiply by 2, no? If you multiply by 2, both sides, r squared sine 2 theta is equal to 2 times 1, get 2. Boom. And this answer is exactly the same, the answer. Very, very good. Very, very good. Any question?
No questions, Professor.
Okay. So I propose to stop here because now we have the complicated part. That we dedicate Tuesday, and I suppose we finish Thursday in the few minutes, and that's it, guys. Review. I send both tests. I send test 4 and final, and you make your own decisions. You take the final or not. I grade both. Suppose you are doing nothing in the final, no problem. The final always increasing the grade and the equation si you are doing well. Si you are doing no well, entonces stay the same. Okay? Okay. Okay, entonces I want to say bye.
Bye. Have a